So now we're going to talk about horizontal stretches, horizontal shrinks. Now I've got two equations written down here. The first one corresponds to vertical stretches or shrinks, and the second one corresponds to horizontal. So if you put a number out in front of your function and use multiplication to say, hey, I'm going to take the whole function by some number, that's going to make it taller or stretch vertically or shrink vertically. Okay, let's go ahead and look at an a value. So here I've got my purple line graphed. I'm going to hide my red one. There's my purple line. Okay, just the standard parent function. I'm going to scale this a little bit better so we can see those points like we're used to. Okay, in fact, I'm going to put a few points on there, like one, ones on there, and 2, 4s on there. Okay, 0, 0, 1, 1, 2, 4. So there those points are. So we can kind of see when we do something to our function if our other new function has those same points. Okay. Now I'm going to add g of x on top of that one. So there's my g of x. It's the same equation. Now notice in the notation there I have an a in front of the j. Why is the j there? Because j is the original function, x squared. Here I've put an a in front of the function. So that's going to cause vertical stuff to happen. And I also have a b in there. But I've left my b, and I will hide all that stuff. My b is just going to be left at 1, and I'm going to show you what a does. A should cause vertical action. So I'm going to change my a to a 2, and as I change my a to a 2, my multiplier out front, you'll watch what happens to the graph. I'm going to go all the way up to 2 right here. Okay? And you can see now, it no longer goes to the same points it had. In fact, I'm going to put a couple of points on my new parabola there. It's got the points, instead it's got 0.11, instead of that it's got 1, 2. It's been doubled its y value has. And I can't even show you the other one. The other one was 2, 4, that's the black dot on there. If I was going to graph him on the new one, he would be at 2, 8. It stretched the y value. And so I'm going to show you where 2, 8's at. Look, he's way up there now. Okay, that's why we call it a vertical stretch. A is 2, it stretches the y values by twice what they were. Here I'm going to make the a a 3. It's going to look skinnier because it's getting stretched even more. Okay, now I'm stretching those y values even more by a factor of 5. Okay, you have to remember what f of x stands for. F of x is what comes out of the function. What's the f of x? A 10 came out. Okay, so it takes the 10 and multiplies it by whatever your a value is. So that's how the stretches work vertically. Now, that a value, though, can have other things besides these big numbers here. It could have fractional numbers in front. When you multiply by fractions, things get smaller. So the y values, you can see now, this is my red one. My red one's getting wider. This is called a vertical shrink. My y values are getting lower. Okay, and that's these fractions. 0.3 is really 3/10. Here's a 0.1. 0.1 is 1/10. It's a really wide parabola. And it will stay much wider as long as I don't go past 1. At 1, I'm the same size. Now I'm skinny. I'm stretched. 1, I'm the same size. Now I'm a fraction. I'm wide. Okay, and notice I'm stopping here at 1. What happens if I go to 0? If a is 0, I'm multiplying the function by 0. And the function becomes 0. Y is 0. There he is, horizontal. So we never put a 0 in for a. That just makes our function go flat and become 0. Okay? If I put in negative values, if I'm negative fractions, spread that up a little bit, negative fractions, all the negative does is flip it upside down. We saw that in the last lesson. So now it's flipped upside down and it's wide. It's vertically shrunk. And I'm going to go vertically stretch it. How do I vertically stretch it? I have to go past the -1. Right now, I'm the same size, just flipped over. Now I'm stretching it vertically, and I'm upside down because they're negative. Okay? And so we got to somehow remove the negative from the conversation because the negative deals with flipping it. Positive, I'm negative. I'm positive, I'm negative. I'm positive, I'm negative. The negative flips it. But the size of the number, am I smaller than 1 or am I bigger than 1? Decides if I'm a stretch or a shrink. And so we say it like this. Hey, if your a is greater than 1, then you vertically stretch. But we have to throw away the negative part of that Okay, so if it's a negative 2, negative 2 is not bigger than 1. So we have to say the absolute value of it. Now if I plug in a negative 2, the absolute value is 2. And it doesn't matter. There the 2 is narrower. Here is a negative 2. And it's also narrower because it's stretched. It's just upside down. But if the a value is less than 1, or its absolute value is less than 1, so now we're talking like a half or negative a half, because negative half, absolute value is a half. It's less than 1. So if we're using these fractions less than 1, now we get wide stretches. Here I'm negative, so I'm wide and upside down. Here I'm positive, but I'm wide because I'm using a 0.7, a 0.5, a 0.3. Okay, so that's how that works. Horizontally now, so now I'm going to set my a value to 1, so it doesn't affect it, same size as the original function. I'm going to play with the b value, the number inside of the parentheses, but still multiplying. But now it's multiplying times the x value, not multiplying the y value. Let's see what the b value does. So I'm going to put some big B's. I'm going to go b is 2. B is 2. Holy cow. That looks like it just did a vertical stretch by a factor of 2. Well, yes, it kind of looks like that. In fact, it looks a lot like that. In fact, you'd have a hard time telling if that was a vertical stretch or a horizontal, what we call shrink. Okay? Now, let's see here. I'm going to put a horizontal shrink of 2 on it. This 2, now you can see it is narrower, so that kind of makes sense with a horizontal shrink. And I'm going to plot a few points. So the blue one there and the black one there on the original. Now watch my new one here. I'm going to shrink it, and I'm going to put, instead of 1, 2, I'm going to cut that in half. Normally my function gives me 1, 1. Now 0.51 is going to be on my graph. It actually, instead of 1, 1, it's half of the x value. Gives me a 1. It shrunk it. I no longer need a 1 to get to a 1. It takes an x of just a half, and I'm at a 1. Same thing here. I'm going to cut this 2 in half and make him a 1, 8. Not a 1, yeah, 1, 8. No, 1, 4 here, because usually I get 2 gives me 4, but now 1's going to give me 4. And you can see that's what happens. It cut my x value in half by putting a 2. Okay, so the 2 here, oops, I just changed something. There we go. The 2 for a b value, if my b is a 2 right there, it actually caused it to horizontally shrink by a half. I got an R, I should get in there. By 1/2. That's why I had to cut these x values in half. Instead of 1, 1, I use 0.51. Instead of 2, 4, I use 1, 4, half of the x value. So the bigger my b gets, the more I actually shrink horizontally. I'm going to play with my b some more. There's my b2, I'm shrunk horizontally. There's my b3, I'm even more shrunk horizontally. Here's a really big b of 10. And I'm shrunk horizontally in that case by 1/10 right there. It's 1/10 as wide is kind of how we speak about it. So how do I make this thing now bigger? I saw how to horizontally shrink it. I put in big numbers for b. But if I want to horizontally stretch it, this is where my fractions come in. There I'm the equal size. Now comes a fraction. Look at a b value that's a fraction. Actually causes it to get wider, and I'm going to use 0.5 because it's the easiest one. There I've got a b of 0.5, but it's actually 2 times wider when I put in a 0.5. Okay, so now if I want to stretch it 2 times wider, I have to use a b value of 0.5. Well, 0.5 is a half. I have to use the reciprocal of how much wider I want to make it. Here I want it 2 times as wide, so I use 1/2, the fraction 0.5. If I wanted to make it 10 times wider, I'm going to make this 0.1. 0.1 is 1/10. His reciprocal is 10. And so it's stretched now horizontally by 10. So it kind of has this inverse sort of relationship. The bigger I make the b, the narrower it gets. And the smaller I make the b, the wider it gets. What about my b's that are negative values? Well, you're not going to notice much if my b's are negative. It looks like it's just doing kind of the same thing there. That's because it's actually flipping it over the y-axis. But because this parabola is symmetric about the y-axis, it doesn't look like it flipped it over. I'm going to change my equation here. I'm just going to make it so it's off-center by putting in a -2 in there. I just shifted it right by 2 is all. And now I'm going to play with those b values. And you'll see the negatives. Here I'm going to put it back to 1. 1. So there it is. I'm going to start making it wide, 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 wide. It's also shifting over a little bit because now it's changing my initial vertex. It's doubling my vertex or tripling my vertex's x value. Okay, so it's moving my x values because it's getting stretched or shrunk horizontally. But now watch me flip it over. I go to negative side, and I'm really wide now. See if I can get him so you can see him a little bit better. I'm really wide because I'm a 0.3. That's going to cause a horizontal stretch. And I'm flipped over the x-axis. Let's go right to a -1. So you can see there I am flipped over. Now I'm flipped over and wider. And now I'm flipped over and narrower. Okay, so that's what's going on. They have this kind of inverse relationship. So let's kind of fill in some notes for this guy. It looks like this. In this one, if your b, absolute value again, not the negative part, if your b is greater than 1, it actually causes a shrink. The big numbers do the opposite of 1 over b, the reciprocal of the b value. And if your b is less than 1, if it's a decimal, it's going to cause a horizontal stretch. And that horizontal stretch will again be by 1 over b. Now you got to remember, oh, aren't they doing the same thing, 1 over b? You have to remember this b, when you're less than 1, is like a fraction. b is like a half. And so when I do the reciprocal of 1 over b or flip it over, I get a 2. And 2 will cause that stretching. Okay? So I say, hey, I want to stretch it by 2. I put a half in there. And that stretches it by 2. So let's answer these questions now. I'm going to erase some of this stuff. We can remember it. All right, this isn't too hard for any of us. On the outside, we keep the number. If the number is big, it stretches. If the number is small, it shrinks. On the inside, it does the opposite of that. If the number is big, it shrinks. And if the number is small, it stretches. All right.